Bivariate analysis examines the relationship between two variables. Its goal is to understand how one variable correlates with or influences another, revealing patterns and dependencies. Let's illustrate using Python and the tips dataset. Consider total_bill and tip. Total_bill is our first variable. Tip is our second. We'd analyze how tip amount changes with the total bill, a key bivariate relationship. Another example. Size, number of diners, as our first variable, and total_bill as the second. We explore if more people lead to higher bills. Even day of the week and tip amount form a bivariate analysis, seeing if tips vary by day.
Bivariate analysis involves examining the relationship between two variables to understand how they interact or correlate. The goal is to determine if there's a statistical association between them, the strength of that association, and its direction. Unlike univariate analysis, which looks at a single variable, bivariate analysis helps uncover patterns, trends, and cause and effect relationships, though correlation does not imply causation, between pairs of variables.
The code begins by importing the necessary libraries: pandas for data manipulation, Seaborn for loading the dataset and creating statistical plots, and matplotlib, pyplot for displaying the plots. It then loads the tips dataset, a classic dataset often used for learning statistical analysis, into a pandas data frame called tips_df and prints its head and info to give an overview of its structure and content.
The first example of bivariate analysis investigates the relationship between two numerical features, total_bill and tip. Total_bill represents the total cost of the meal, and tip represents the amount of money left as a gratuity. The code calculates their Pearson correlation coefficient, which quantifies the linear relationship between these two variables, and then generates a scatter plot to visually represent how the tip amount changes with the total bill.
The first scatter plot visually confirms the positive correlation between total_bill and tip, showing that as the total bill increases, the tip amount generally also increases. The first box plot clearly shows the distribution of total_bill across different days, suggesting that total bills might be higher on weekends, Saturday and Sunday. The second violin plot compares the distribution of tip amounts between lunch and dinner, illustrating potential differences in tipping patterns based on the time of day.